Hello everyone and welcome back to another maths lesson. Today's learning objective is to build the 12 times table and count in steps of 12 from 0. So I'm starting today's lesson with another 100 square. Okay, so I'm going to be counting in steps of 12. So our first lot of 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's my first mark. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, so 12 doubled, so times by 2 equals 24. So our 12 is just double here to 24. Counting another lot of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now at this point I'm going to stop you and ask you maybe to pause the video and see if there is a pattern that you have noticed. The pattern I can see here, look at the second number, 2, 4, 6. Look at the first number, 1, 2, 3. So what's going to happen next? 1, 2, 3. I think it's going to be then 4. And this is the 2 times table, it looks like here to me. 2, 4, 6, 8. 48. What's going to happen next then? If we can see down, it almost looks like it's going down the stairs a little bit here. If we go into the next part of the 2 times table, 8, 10. So it's going to be ending in 0. And 1 more than 4, if we follow this pattern down, is 5. Oh, but that's not going to work, is it? Because we've gone up into the 10. So our 10s have changed. It's not going to be 50, because that would only be a difference of 1, 2. So if we add that 2 to our 10, it's going to be 60. Okay, now from here, let's see, because the pattern might change again here. We're going to add another 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 72. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 84. Oh, it looks like there's similar patterns going on again. Down here, look. 2, 4, 7, 8, 2, 4, 6, 7, 8, 9. So it's going to be 96. So I wonder if at home you can think about what number is going to come next in the 12 times table. Okay, so another simple way of building your 12 times tables is to look at your doubling. So 12 times 1, nice and simple there, is going to be 12. If we double our answer, when we look here, because double 1 is 2, so double 12, you know that double 12, double 2 is 4, and double 1 is 2, so we get 24. And we can double it again, because we know double 2 is 4. So doubling this answer will give us 12 times 4. 4 times 2 doubled, 8. 2 times 2, 4. Nice and easy this, isn't it? Again, we can double it again because double 4 is 8. Now, being careful this time because we might have to regroup here. Double 8 is 16. Double 4, well it isn't actually 4 though, is it? Because this is actually 4t. Okay, those are my 10s and my 1s. Excuse my terrible handwriting here. So double 40 is 80. So I might just have to rejig this ever so slightly and do my little bit of column addition. Goodness me, it's hard to write using a mouse on my computer. So 6 add 0 is 6, 1 add 8 is 9, so 96. So also doubling is a convenient and quick way to work out your 12 times tables without using your fingers or without even using your memory. When you come to stretch it, you will see that Colin has made another mistake. Now I'm focusing on the 8 times table because you should all know your 8 times table, and that's absolutely fine. And I'm going to use my 100 square again because it's a fantastic way of showing when Colin's made a mistake and how to correctly answer questions. So Colin thinks he's counting in the 8 times table. 8, 18, 28, 38, 48, 58. Maybe the reason he's done this is because he thinks that when you're counting in the 8 times table, it's always going to have an 8 on the end. Let's look closely then here at the questions. 8, 18, 28, 38, 48. What are these jumps of? I'm sure many of you are shouting at me. Mr. Nash, he's jumping in steps of 10. That's correct. If he's jumping in steps of 10, is he counting in the 8 times table? No, he's not. Okay, so if you were to follow Mr. Nash's advice from before, where we said you could do doubling, well, you know 8 double 8 is 16. If you were to double that, it would give you 32. So let me just highlight some of these. If you were to double that, it would be 64. Now I know I'm not actually counting the 8 times table here, but what I'm doing is I'm showing Mr. Nash that I have an understanding here that these are multiples of 8 here. and there's problems because this is the times tables that Colin has shown in his answer. So if I show some examples, maybe an array, maybe using 100 square, that's how I'm going to make sure that I'm answering my questions correctly. Finally then, you will have a stretch it that looks at multiples of 12 and whether they're always even. Now I've gone for multiples of 11 are always even. Okay, now I'm going to get out my highlighter, but first and foremost I'll go for a nice pink. I need to think already which numbers are even, because sometimes people forget these and that's fine. Numbers that are even will end in 0, 2, 4, 6 or 8. Numbers that are odd will end with 1, 3, 5, 7 or 9. So if I go back to the 11 times table, which we looked at last week, let's see if we can remember those. Okay, so jumping in our steps of 11, as we've probably remembered, 11, 22, 33, 44, 55, 66, 77, 88, 99. Next would be 110, 121, and 132. So it says here, multiples of 11 are always even. Always, sometimes, or never. So here are our even numbers, here are our odd numbers. Do these always end in even numbers? Well, let's look. 1. Well, no, because that's odd. 2. Yes, because that's even. 3 is odd. 4 is even. So it seems like there's a pattern here that's emerging. Odd, even, odd, even, odd, even. So in my answer, am I going to say always? No. Am I going to say never? Well, no, because sometimes it is even. So my answer here would clearly be sometimes. So having a look at your stretch it, see if multiples of 12 are always even, or if there are any odd numbers in there. Finally then, we have our maths challenge for today. It says, in a classroom of 24 children, 1/8 are boys. Firstly, what fraction are girls? And then, how many children are girls? That is all of your maths for today. Thank you very much for joining me again. Bye.